Welcome to Electric Circuits Lab. Today we are going to explain about simulation and experimental verification of electric circuit problem by using Kirchhoff voltage law. So we are going to verify the Kirchhoff voltage law. For that we need circuit diagram. So this is the circuit diagram. This, as per the circuit diagram, we have to connect the circuit by using the breadboard. So all of you note down here in this RPS we are going to give the power supply by using RPS to the circuit. Then the 30 volt first voltage source is connected across the RPS to measure the input voltage. Then so this V is an input voltage, then V1, V2, V3. According to the Kirchhoff voltage law, sum of the potential rise is equal to sum of the potential drop. So according to that, the V total equal to V1 plus V2 plus V3. This is the Kirchhoff law state that. So we have to experimentally going to verify that. So according to the circuit diagram, now we are going to see in the breadboard connections. So for this experiment, we need RPS, one voltmeter for input power supply voltage, then 3 voltmeter for V1, V2, V3. As per the circuit diagram, we have connected 3 resistor. First one is on 1 kilo ohm, another one is on 10 kilo ohm, another one is on 2.2 kilo ohm. As per the circuit diagram already given in the circuit, we are connecting these connections here. That voltmeter, that means the voltmeter connected parallel with the supply, then each resistor across one voltmeter is connected here. So circuits already connected in as per our circuit diagram. Now we are going to verify the Kirchhoff voltage law. So always in RPS we have to keep all those things is minimum. Then in this RPS, first of all we have to check the current should be maximum. So we have to by using the volume adjuster, we have to increase the maximum value as a current. Now gradually increase the input voltage. At the time same we have to verify all the voltmeters are indicated somewhat value. We have to verify by using the voltmeter reading. So now I am going to check the for 10 volt. For 10 volt, this is the input. Here we can voltage also 10 in the RPS. Same reflected in the voltmeter, input voltmeter 10 voltage. So this is the V total. Now then we are going to see about the voltmeter 1. Take the reading. This is the first resistor across the voltmeter. So this voltage becomes 1.8. Then second voltmeter becomes 5. 1.8 plus 5. Then third voltmeter becomes 3.2. So according to the Kirchhoff voltage law, 1.8 plus 5 plus 3.2 totally 10 volt. So according to Kirchhoff law, V total equal to V1 plus V2 plus V3. Now the Kirchhoff law has been verified successfully. We have to take the reading as well as manual calculation we have to calculate. Then same thing going to verify in the simulation also. By using the MATLAB we can get the simulation also. So all those things correct means the Kirchhoff law has been verified.
Now we can see simulation of verification of Kirchhoff voltage law. So already we did the experimental verification of Kirchhoff voltage law. For the same circuit, we are going to take the simulation. For that, first of all, you have to open the MATLAB simulation software. If you're opening the MATLAB simulation software, this command will window like this that will come. So from this window, you can go for new Simulink module. So if you press the Simulink module, the corresponding Simulink, untitled Simulink will be open like this. From this Simulink, you can go for library browser. From the library browser, What are the things we have to do? First of all, we need voltage source. For voltage source, you have to go for DC voltage source. So you can search in the DC voltage source, that will come. You can take it as. If we need any resistance means, we'll go for again library browser, search it as RLC branch. If you search like this now, the series RLC branch will come. So keep as it is and double click that value. The branch type will only the resistor. You put resistor, the value we can change accordingly. Give OK. So this is the resistance. For measurement of voltage, you can go for like this voltage measurement library browser. So if you search in the voltage measurement, so you'll get the same similarity like this. The output can be determined by the display unit. So you search in library browser. Similarly for display, search in display. So you will get the display here. So keep as it is. The output of the voltage measurement should be given to the display. After completing the circuit as per the circuit diagram, we have to search the library browser and go to the power GUI. For all the experiment or any circuit of simulation, we should need the power GUI for execution of the program. You can keep any side of the particular circuit and execute that. So this is the procedure. We have to get the component from the particular library browser for the given circuit. So let will have already simulated the KVL. This is the simulation model of KVL. So now we can set the value here. The voltage becomes 12. Then resistance becomes 2.2 kilo ohm. So 2200 ohm. The another resistance will be 10,000 10k. The last resistance will be 1000 ohm. So the voltage measurement blocks is there. The output of the voltage measurement given to the display unit. So the power GA is copied here. After completion of the entire circuit, you'll go for the click the run button. So you'll get the output in the display unit. If you are not saving the program, you can't able to get the output. So you have to save the corresponding program in the proper file. The file name should be M-type file. After that completing the save the program, we can get the output like this in the display unit. We can compare with the experimental verification. So this is the simulation and experimental verification of Kirchhoff voltage law.